The square root of 32, remember that there is a square. It's called square root because there's assumed to be a 2 in here, and that becomes important. I have my list of squares here from 1 to 100, and 32 is not on this list, but I can you have to find the largest one that goes into that. So I can divide 32 by 16. 32 divided by 16 is 2. So whatever you get when you divide it goes inside the radical, and whichever one worked for you, the 4, whatever's in front of your exponent goes outside the radical. So the square root of 32 is 4 times the square root of 2. Then I have a minus sign. And the square root of 98, well, 98 divided by 49 is 2. So the answer that you get after you divide goes underneath the radical, and whatever's in front of the exponent of the combination that worked, the 7, goes in front. So once you have your radicals simplified, you leave them alone. So that's the square root of 2. And you put the outside together. This is 4, take away 7, which is negative 3. So negative 3 times the square root of 2 is the answer to that one. This next one, 27, is not on the list. But, let me change colors so you can see what I'm doing here. I can do 27 divided by 9. So 27 divided by 9 is 3. So that goes under your radical, and whatever's in front of your exponent there, the 3, goes out front. But I already had a 2 out front as well, so I'm just going to put a 2 with that. Okay, then a minus sign. The square root of 18, you can do 18 divided by 9. 18 divided by 9 is 2, so that's going to go under your radical, and whatever's in front of your exponent goes in front of your radical, so that's a 3. But that one already had a 2 in front of it as well, so I just put that with it. Okay, 75. 75, you can divide by 25. So 75 divided by 25 equals 3. That goes under your radical. Since we use the 25, the 5 out front goes in front of your radical. There was a plus sign there, and there were no numbers in front of the original radical. So what we can do now is 2 times 3. I have 6 times the square root of 3 minus 6 times the square root of 2 plus 5 times the square root of 3. Now I can put the square roots of 3's together. Again, you leave your radical alone, so it's still going to be the square root of 3. 6 plus 5 is 11. And then I don't have any other square roots of 2, so I just write down my minus 6 square root of 2, and that is the answer to number 2. Number 3, the square root of 4 is 2. And then, remember there's a 2 in here. For my b's, 2 goes into 3 one time with 1 left over, so the leftovers go inside. Then I've got a plus sign. The square root of 49 is 7. And for my b's, 2 goes into 3 one time with 1 left over, so the leftovers go underneath. And then a minus sign. The square root of 100 is 10. And for my b's, 2 goes into 3 one time with 1 left over. So all of these are the square root of, actually all of these are b's times the square root of b. So you just add the numbers in the front. So 2 plus 7 is 9. 9 take away 10 is negative 1. So negative 1b times the square root of b is the answer for that one. The next one, The square root of 25 is 5. So I've got 4 times 5 minus 10 plus the square root of 5. That can't be simplified. So 4 times 5 is 20. 20 take away 10 plus square root of 5. So I've got 10. 20 take away 10 is 10 plus the square root of 5 is the answer to that one. Okay, the next one. 175, we can divide that by 25. So 175 divided by 25 is 7, I believe. It is 7. That goes underneath my radical. And what I used there was 5 squared equals 25. So the 5 goes outside the radical, and then it already had a 6, so that also goes with that. Then I have a minus sign, 12. Well, let me see, 4 squared equals 16, 2 squared. Okay, 12 divided by 4 is 3. So whatever you got when you divide goes under your radical. The 4 is what works, so whatever's with the exponent goes outside, so that's a 2 there. And then it had a 4 originally there. Okay, the next one, 63. Well, 3 squared is 9. If you have a list made out, you can continue to use it. So I'm going to take 63 divided by 9. That equals 7. So whatever you get when you divide goes under the radical, and I use the 9, so the 3 is with the squared, so the 3 goes outside. So then I also had, well, I had a minus there, and I also had a 7. Okay, so that's 30 square roots of 7 minus 8 square roots of 3 minus 21 square root of 7. Okay, so square root of 7, I've got 30 take away 21 is 9. And then I just have a minus 8 square root of 3. I can't do anything with that to combine those. Number 6. Number 6, these are cubed roots. So I need a list of cubes. So 1 cubed equals 1. 2 cubed equals 8. 3 cubed equals 27. 4 cubed equals 64. And 5 cubed equals 125. That's enough. Okay, 108. Well, let's do 108 divided by 64. Nope, 108 divided by 27 I don't believe will work. Yep, 27 times 4. So I can use this one here. 108 divided by 27 equals 4. So that goes in my radical, cubed root of 4. And whatever was in front of my exponent goes out front, so that's a 3. And the original problem had an 8 there out front. So plus the cubed root of 32, well, 32 divided by 8 equals 4. So whatever you get when you divide it goes underneath, and whatever's out front, the 2 goes in the front. And there was nothing else with the original radical. Alright, so I've got 24 times the cubed root of 4. Again, once you get that radical, you leave it alone. You don't touch it again. So I've got cubed root of 4. And 24 plus 2 is 26. So 26 times the cubed root of 4 is the answer to that one. Okay, the next one. The square root of 4 is 2. And I can't take an a out, so that's got to stay inside. Let me leave some space there, though. For my b's, 2 goes into 7, 3 times with 1 left over, and my original problem had an a in there as well in the front. Okay, so that one's done. Then minus sign. The square root of 16 is 4. For my a's, 2 goes into 3 one time with 1 left over. And for my b's, 2 goes into 7 3 times with 1 left over. Plus sign. The square root of 49 is 7. For my a's, 2 goes into 3 one time with 1 left over. And for my b's, 2 goes into 7 3 times with 1 left over. So all of these are AB cubed times the square root of AB. So I just deal with the numbers in the front. 2 take away 4 plus 7. 2 take away 4 is negative 2 plus 7 is 5. So 5AB cubed times the square root of AB, and that one's finished. Okay, cubed roots again. So 1 cubed is 1, 2 cubed is 8, 3 cubed is 27, 4 cubed is 64, 5 cubed is 125, 6 cubed, I think that's 216, is 216, 7 cubed is 343, is 343. Okay, so 250. Well, I can do 125. 250 divided by 125 equals 2. So I'm going to have the cubed root of 2. And then for my x's, I can't take 3. 3 doesn't go into 1x, so the x has to stay inside. And for my y's, 3 goes into 3 one time, so I can take a y out. Plus, okay, 54. 54 divided by 27 equals 2. So that's the cubed root of 2. And then I can't take an x out, it stays. I can take one y out, and the original problem already had a 6 out there, outside. So plus, square root of 16 is 4. So 4y times the cubed root of x. Oh, I'm sorry, I'm not doing square roots. So let's fix that. We're doing cubed roots. So I want to do 16 divided by 8 equals 2. Oh, I erased too much there. Let me see what I got here. Okay, so you got 2, and then the x stays in, and the y you took out, and then I had a 6 there, and I had a 2 here, and 27 I had a 3, and a y that you took out, and the x that couldn't come out. Okay, plus cubed root of 16. Okay, I've got the cubed root of 2, and I have an x, and then I already had a y outside. 8, 2. So the 8 worked, so I have to use the 2 outside, and I already had a y outside. Sorry, everything's crammed together. So I've got y times the cubed root of 2x plus 18y times the cubed root of 2x plus 2y times the cubed root of 2x. So I've got the cubed root of 2x. Okay, this is like 1y, and I've got a y. 1 plus 18 is 19, plus 2 is 21. All right, that one's finished. Okay, so the cubed root of 13, nothing I can do with that. So I'm going to leave that as negative 8 times the cubed root of 13 plus 1 times the square root of 13 minus 7 times the square root of 13. I can't simplify any of those radicals, but I can have my negative 8 times the cubed root of 13. For my square root of 13, I can put those together. 1 take away 7 is negative 6. Okay, for multiplying, you don't touch the radical. You just multiply the inside. So 2 times 3 is 6, plus, don't touch the radical, 2 times 5 is 10, and that doesn't simplify. Okay, so this is the square root. 6 times 6 is 36, and I have a z minus sign. The square root of 6, and then z times z is z squared. Okay, this one can be simplified. The square root of 36 is 6. Can't do anything with the z, so you leave it under the radical. So 6 times the square root of z minus, okay, this, the square root of 6, I can't take the 6 out, but I can take the z out because 2 goes into 2 one time, so I can take one z out. So 6 times the square root of z minus z times the square root of 6 is the answer to that one. Okay, this next one, numbers on the outside get multiplied together and numbers underneath the radical get multiplied together. So here's how this works. 7 times 8 is 56, and the square root of x times x is the square root of x squared. Then 7 times negative 5 is negative 35, and I have a square root of x there. 5 times 8 is positive 40, and I also have a square root of x. 5 times negative 5 is negative 25. Now this first one, I can take the x out because 2 goes into 2 one time. So this one's going to be a 56x. For my square roots of x, negative 35 plus 40 is a positive 5, so that's plus 5 square roots of x minus 25. And the next one, I have cubed roots. So a times a is a squared. And then the cubed root of a times 11 is 11 times the cubed root of a. And then negative 9 times the cubed root of a is negative 9 times the cubed root of a. And then negative 9 times 11 is negative 99. Cubed root of a squared, we can't do anything with that because 3 doesn't go into 2. So I leave it like it is. For my cubed root of a, 11 take away 9 is a positive 2. And then I have the negative 99.